Laws of indices. Up next, these two laws of indices are some of the favorites of teachers. So let's take a look at them. First one, a to the power of 0. Anything to the power of 0 will give you value of 1. Next, a to the power of negative 1. What happens to the letter a? This is actually written as 1 over a. What does this mean? For example, if I have the number 2 to the power of negative 1, 2 is actually considered as 2 over 1. So what I'm going to do, I'm going to change this to a positive index form, and I'll need to flip the number. So I'll get 1 over 2. Then now the power will change to become positive. So if let's say I will have a to the power of negative 3, what does this mean? This means the negative power is telling me that I need to change a to become 1 over a. And the power 3 actually is meant for a, so I'll get a cubed. 1 over a cubed. Simplify the following, leaving your answer in positive indices form. Now let's take a look at the first question. 3e to the power negative 4. This negative power negative 4 belongs to which number? 3 or the letter e? Or is it the whole thing? 3e. Now in this case, actually the power negative 4 here only belongs to e. It does not have any effect on the number 3. So what happens? 3 stays where it is, and I will need to shift e to the denominator. So it will be e to the power of 4. What happens if we have a fraction? For example, like in B, I have a numerator and a denominator. The whole thing to the power of negative 3. This negative power tells me that I need to change the whole fraction. Whatever that's in the numerator will now need to shift. So what do we do to the whole fraction? We will need to flip the whole fraction. And I will get 5x over 2p squared q to the power negative 3 holding. Now after we flip the fraction, the negative sign is gone, the power will become 3. Now what do you notice inside this value? I have a q to the power of negative 3 here. So what do I need to do to q? This power negative 3 is only for q, so only q needs to shift. So we can change this to 5x over 2 will stay where it is, p squared stay where it is, and q to the power negative 3 will now change to q to the power of 3 in the numerator. The power from negative 3 changes to become positive 3. And the whole thing we still need to cube it. Then next we need to handle this power 3. So 3 is applied to everything inside the bracket. So we will be able to get 5 to the power of 3. That gives me 125. Please don't tell me 5 to the power of 3 is 15. Okay, use your calculator. Then we'll get x to the power of 3 and q to the power of, using the last law that we have learned, this will be q to the power of 3 times 3, 9. 2 to the power of 3, that will give me not 6, but 2 times 2 times 2 is 8. And I will have p to the power of 2 times 3. That will give me p to the power of 6. Next part of the question. Part C. We have 3GF holding to the power of 3. What do you think we need to do down here? This power have to be applied to every term, every letter, and every number. So let us try to simplify these. I will have 3 to the power of 3 is 27. G to the power of 3, F to the power of 3. Over our denominator, we notice that there is a negative power. This negative power 2 belongs to who? 5, G, or 5G? Well, it belongs to only G. So what happens now? I need to change this to the positive index form. So 5 will remain in the denominator, but the letter G will shift to the numerator and the power will now become G squared. There will be no more negative power. Times 10F 2G. What can we do? We can multiply the numerator with the numerator. So 27 times 10, that gives me 270. G cubed times G squared, that gives me G to the power of, when you have multiplication, the power add together, 5. F to the power of 3 and F. This is actually F to the power of 1. So when you have multiplication, the power add together. So it will be F to the power of 4. Over the denominator, 5 times 2 gives me 10 and G. And we'll be able to get the answer. 270 divided by 10 gives me 27. G to the power of 5, and there's a G in the denominator. Which one has more power? Our numerator. So we are left with G to the power of 4 and F to the power of 4. So this will be our answer. Next question. D. 5 x to the power of negative 4 and y to the power of 8. What do we need to do to x? We need to move x. So x has a negative power. It will now shift down to the denominator. So we'll have 5 in my numerator, y to the power of 8 in the numerator, over x to the power of 4. Now division, so we do the divide. 15x to the power of negative 3, and y to the power of 6. Now this power negative 3 only belongs to x. So only x need to shift, need to move. So what will we have? We will have 15 y to the power of 6 in the numerator, and x to the power of negative 3 now need to move. So we will have x to the power of 3 in the denominator. Now this is division. So what can we do to division? We can change the division to multiplication. Which fractions need to flip? The one at the back. So 5y to the power of 8, x to the power of 4, x cubed over 15y to the power of 6. Now multiplying the numerator with the numerator together and the denominator with the denominator, I will get, the only number is 5, y to the power of 8, x cubed over, the only number is 15, y to the power 6, x to the power 4. Simplifying this, I will have 5 over 15 gives me 1 over 3. Y to the power 8, y to the power 6. Which one has more power? So it stays in the numerator. And how many are we left with? Y squared. X to the power 3, x to the power 4. Which one has a bigger power? The denominator. So we are left with x. Now, is it necessary for us to write the 1 in this case? So, no. We have y squared already. We don't need to write 1 y squared. So we can erase away 1. And this will be our answer.